Hi everyone, I thought I'd make a quick video to go over this ET50 from the photosynthesis lab and explain in a little more detail how I want you to graph your data from this particular lab. Okay, so we're going to use estimated time of 50% disks floating to show photosynthesis rates in this experiment. And this is how we do it. So your data from the experiment will be number of disks risen. So you should have a couple of data tables that show disks risen in your control in your experiments. Okay, so for example, if you were to do an experiment like this where you're looking at the effects of increasing bicarbonate solution, so you're increasing the amount of dissolved sodium bicarbonate in your solution that you're performing your photosynthesis experiments in, you might get some data like this that shows over a 10-minute experimental time course how many of your 10 disks rise at each time point. So this should, the experiment should be similar to what we did, but it's not exactly the same variables that we looked at in the lab. But just note here that you're counting the number of disks risen over a time period of 10 minutes. I think your lab, we did 15 minutes, not a big deal. But when you look at the key over here, the black line is 0.2% sodium bicarbonate, the red line is 0.4, and the green line is 0.6. And so you can see just from the data that the 0.6, which is 3 times the normal amount of sodium bicarbonate, the disks rise faster. But to show it in a little more detail, to show the rate, we're going to calculate it as ET50. So again, how you do that is you're going to calculate the estimated time for 50% of your disks to rise. So 50% of 10 disks is 5. So you calculate 5 disks and the time it takes for those 5 disks to rise in each experiment. So for our control, the ET50 is 5.5 minutes. If you look at the red line, the ET50 for 0.4 bicarbonate is 4.5 minutes. And if you look at the number of disks risen, number of in the 0.6, 5 disks risen for your ET50 will be 3.5 minutes. Okay, so you can express those values as 5.5 minutes, 4.5 minutes, 3.5 minutes as ET50 values. So if you change your graph slightly just to have ET50 values in minutes on the y-axis, this is the data that you could get. Notice that down here on the x-axis, instead of covering time now I'm showing you the concentration of sodium bicarbonate going from 0.1 to 1%. Okay, so keep in mind 0.2 was our control, 0.4 is our 2 times the normal amount experiment, and 0.6 is 3 times the normal amount. So if we have ET values over here, you can see that for the control, it was 5.5. For 0.4, it was 4.5, and for 0.6, it was 3.5 minutes. So the ET50 there is essentially showing that inverse relationship between the ET values and the rates of photosynthesis. So that's sort of tricky to visualize. So basically what it's saying, you can see from the title of my experiment that the ET value goes down as you increase the concentration of sodium bicarbonate. But because of that tricky relationship between ET50 and photosynthesis, you might think something else. But basically what that's showing is that for ET50 value, it decreases as sodium bicarbonate goes up. So that's saying, though, that photosynthesis rates increase as you increase bicarbonate solution concentration. So that the problem with this is that the downward trajectory, the negative slope here, makes it seem as if something's decreasing, when in fact photosynthesis rates are increasing as you increase sodium bicarbonate concentration. So we're going to change our data a little bit and express it as 1 over ET50. Okay, so this will help us to avoid the negative slope, and it'll show your data. It'll show your data instead increasing as the concentration of bicarbonate in your solution increases. So if we calculate it 1 over the ET50, you get a value of 0.18 for your control, 0.22 for 0.4% bicarbonate, and 0.29 So you can do this for your experiment. The second experiment that you did was light intensity. The third experiment, I'm not asking for data, but you can visualize this in a similar fashion. So if we plot that data on a graph now that shows rate of photosynthesis, which is your dependent variable over here on the y-axis, and the unit being 1 over ET50, you see we only have to go all the way up to 0.4 because our values lie between 0 and 0.4. Again, if we're showing down here, and I forgot to label that, but it's sodium bicarbonate solution concentration. Our control is this 0.2 value, which we had said previously was 1.8 or 0.18, excuse me. And 0.4's value is right there, 0.6 value is right there. So we show that slope as a positive slope, and the rate of photosynthesis increasing as you increase sodium bicarbonate rates. Okay, so I hope that's helpful for completing your graphs. We will talk about this in class soon, so I hope that helps.